Hello, my dear students. Today, let us discuss about a hydrograph. Hydrograph is a graph showing variation of discharge with time at a particular point of history. It shows the time distribution of total runoff at the point of measurement. As the runoff includes the contributions from surface runoff, subsurface runoff, and groundwater runoff or base flow, the hydrograph can be regarded as an integral expression of the physiographic and climatic characteristics that govern the relationship between rainfall and runoff. The factors affecting the hydrograph at a place being complex and interrelated. A basin may not produce two exact hydrographs with two similar precipitations as input, nor can two basins of the same drainage area produce the same flood hydrographs with similar precipitation. Since a hydrograph is generated from runoff due to precipitation resulting from either an isolated storm or a series of consecutive storms, it is also known as a storm hydrograph. The hydrograph resulting from an isolated storm will be a single peaked hydrograph, while there will be a multi-peaked hydrograph resulting from a complex storm. Okay, so this is a graph. It is time versus discharge. Next, let us see what are the components of hydrograph. This is a figure shows a single peaked hydrograph resulting from an isolated storm. Okay, here the rainfall hydrograph along with infiltration curve is shown on the top of the diagram. Okay, here there are three essential components of a single peaked hydrograph resulting from an isolated storm. The first one is rising limb, that is the portion A to B, and the second one is the peak or crest element, that is the portion BPC, this portion BPC, and the recession limb, that is CD. Okay, so this is the rising limb, AB is the rising limb, and BPC is the peak or crest element or segment, and CD, that is the recession limb. Let us see one by one in detail. Rising limb. The rising limb AB is the ascending portion of the hydrograph corresponding the increase of discharge due to gradual formation of storage in the channels existing in the area and also over the watershed surface. The rising limb is also known as the concentration curve. In the early period of a storm, there will be initial losses as well as high infiltration losses, and hence the discharge rises slowly. As the time increases, the initial losses stop and the infiltration rate also decreases. Due to this, more and more discharge from the distant parts reach the basin outlet. Point A is the starting point while B is the point of inflection. The shape of the rising limb is controlled by the characteristics of basin and duration, intensity and uniformity of the rain. The initial portion of the rising curve is concave due to the following reasons. The first one is the greater losses due to interception, surface evaporation and infiltration during initial period of rainfall. Second one is heavier concentration of area between adjacent isochrones is laid between the middle and upper part of the watershed. This is about rising limb. Let us take a second point, a peak or the crest segment. The peak or crest segment includes the part of the hydrograph from the inflection point B on the rising limb to an inflection point C on the recession limb. Crest segment is one of the most important component of the hydrograph because it indicates the peak flow rate. The peak represents the arrival of the flow at the outlet from all the parts of the basin. For large catchment, the peak flow point P occurs after the a cessation of rainfall. The time interval between center of mass of rainfall to the peak is controlled by the characteristic of both the basin as well as the storm. Next, let us talk about the recession limb. The recession limb extends from the point of inflection point C of the crest segment to the point D, the point of commencement of the natural groundwater flow. The recession limb indicates the storm contribution from surface storage, which includes both the surface retention and channel storage, interflow, and groundwater flow, since the depletion of this retention storage takes place after the cessation of rainfall. The shape of the recession curve depends only on the basin characteristics and is independent of rainstorm characteristics. The recession curve can be considered as a rate of discharge resulting from the draining off process. Next, let us see about unit hydrograph. What is this unit hydrograph? Unit hydrograph is a hydrograph representing 1 centimeter or 1 inch of runoff from a rainfall of some unit duration and specific areal distribution. Duration refers to the duration of a runoff producing rainfall excess that results in a unit hydrograph. For example, if a unit hydrograph uh, results from a 3 hours unit rainfall duration, it is known as a 3-hour unit hydrograph, meaning thereby a hydrograph produced by surface runoff from a storm lasting for 3 hours and yielding rainfall excess of 1 centimeter. The unit duration may vary from 1 day or large catchments to a few hours for a small catchments. Experiences have shown that best unit duration is about 1/4 of the basin lag, the time from the center of mass of the net rainfall to the peak of the hydrograph. Unit hydrograph method is employed to calculate the direct runoff hydrograph at the watershed outlet given the rainfall excess produced by the storm event. Basic assumptions of unit hydrograph. The effective rainfall is uniformly distributed within its duration. The effective rainfall is uniformly distributed over the whole drainage basin. The base duration of direct runoff hydrograph due to an effective rainfall of unit duration is constant. The ordinates of unit hydrograph are directly proportional to the total amount of DR of each hydrograph. For a given basin, the runoff hydrograph due to a given period of rainfall reflects all the combined physical characteristics of basin. Then let us see how to construct the unit hydrograph. A unit hydrograph method is used for the estimation of the maximum flood discharge of a stream as well as for developing a flood hydrograph corresponding to any anticipated rainfall. In order to derive the unit hydrograph from storm hydrograph of same unit duration, the following steps are followed. The first one, from the past record, select a hydrograph resulting from an isolated, intense, short duration rainfall over the entire drainage basin. Separate the base flow or groundwater flow from the direct runoff. Subtracting the ordinates of base flow from the total ordinates, find the ordinates of direct runoff. Next is the construction of unit hydrograph. So this is a unit hydrograph, discharge versus time. This is a base flow, okay, and this is unit hydrograph, and this is the flood hydrograph. Compute the depth of the direct runoff as under. Depth of direct runoff is equal to volume of the direct runoff divided by area of the drainage basin, that is equal to 0.36 into summation of O into T divided by A. This is in centimeter, where a summation of O, that is equal to sum of direct runoff ordinates in cumex. T is equal to time interval in hours between the successive ordinates. A is area of drainage basin in square kilometers. By dividing each of the direct runoff by the depth of direct runoff, the ordinates of the unit hydrograph are obtained. That is, ordinates of unit hydrograph is equal to ordinate of direct runoff divided by direct runoff in centimeter. The application of unit hydrograph. Once a unit hydrograph for a duration time has been developed for a basin, the storm hydrograph for that basin or any other storm of different intensity but the same duration can be easily developed. To draw maximum flood hydrograph for the design of spillways, it can be used for flooding and flood warning based on the observed rainfall in the basin. To determine runoff from a storm of a unit duration, there are different methods of derivation of unit hydrograph. The first one is method of superposition and second one is S-curve method. Let us discuss about method of superposition. If a unit hydrograph is available and it is desired to estimate a unit hydrograph of n duration or unit hydrograph where n is integers which can be easily determined by posing an unit hydrograph with each graph separated from the previous duration or unit hydrograph. Let us take this example. Here this is a given ordinate of the 4-hour unit hydrograph. Derive the ordinates of a 16-hour unit hydrograph for the same catchment. Okay. Now, this is given, only this is given, okay? This is the answer solution. So, only the first and second column is given. That is the given the ordinate of the 4-hour unit hydrograph. Derive the ordinates of 16-hour unit hydrograph for the same catchment. How to do? So, this is given time 0 hour, 4 hour, 8 hour, 12 hour, 16 hour, 20 hour, 24 hour, 28, 32, 36 till 56 hours. And here 4-hour unit hydrograph, that is discharge is given 0, 20, 80, 130, 150. Okay. Now, what you have to do, you have to construct or derive the ordinates for 16 hour. So, this is for 4 hour. So, next column is for 8 hour. Okay. Next column is for 12 hours. So, you have to do it. 4 is already given. You have to construct for 8, 12 and 16. Let us take for the first this one. So, there are 4 steps are there. So, 16 divided by 4, that is 4 hours. So, 4 ordinates you have to do, construct. In that, one ordinates is already given. So, write that. That is for the first ordinate 0, 20, 80, 130, 150. That same one. Next, for the second ordinates, you have to start with the 4 hour. Every 4 hour, you have to draw the ordinate. So, start from 4. Same thing. 0, 20, 80, 130. Right? But from the 4 hour. Okay. Next is in the third column, you have to start from 8 hour. Again, the same ordinate 0, 20, 80, but it has to start from 8. Next is 12. Again, you have to start this 0, 20, 80, 130, but from 12. Okay. So, first one is the given value. Directly write that. For the second one, you have to start from 4 hour. Whatever the given, start from 4 hour, 4, 20, 80. So, till this it comes. And next for 2, that is starts from 8 or for the 3 it is start from 8 and for 12 that is for 4 starts from 12. So once it is done, add this. This is the column total runoff, that is 5. Column 5 is equal to 1 plus 2 plus 3 plus 4, that is 0. 20, this is 20. 80 plus 20, 100, 130 plus 80 plus 20, 230, then 150 plus 130 plus 80 plus 20, 380, add all these things. And next, last column is this column 5 divided by 4, okay, 16 hour duration. So, this is 0. 20 divided by 4, 5, 100 divided by 4, 25, 230 divided by 4, 57.5. Like that, for all this values has to be divided by 4. So you will get this. This is the 16 hour unit hydrograph. Thank you.